Hi students, welcome again to our YouTube channel. So today we are going to start part 3 of the previous paper AQA 2020 A level. So today we will proceed from question number 7 because last time we did question up to question number 6. So the question number 7 is the melting point of xenon tetrafluoride is higher than the melting point of PF3. Like if you see here, there is like Xe and F4 is higher than the melting point of PF3. Explain why the melting point of these two compounds are different. In your answer, you should give the shape of each molecule, the first thing. Then explain why each molecule has that shape and how the shape influence the forces that affect the melting point. So that is the 6 marks question. So actually we have to find why the melting point of xenon tetrafluoride is higher than PF3. So first of all, we have to draw the structure of xenon tetrafluoride. So as we know that xenon is present in the noble gases that contain, like normally, how many electron? Total 8 electron. So I am going to show you 1 2 like 3 4 5 6 7 8. Okay, and actually there are the 4 fluorines that are combined. So actually xenon will make a square planar geometry when the 4 fluorine will attach to xenon. Okay, so here you can see that now the xenon, the geometry is square planar. Okay, the geometry is square planar, and now the xenon contain how many bond pairs? So there are total 4 bond pairs and 2 lone pairs. So you can write here 4 bond pairs, 2 lone pairs around xenon. Okay, that is the first condition. Now in case of second, like in case of PF3, I am going to show you with different color. Okay, so that is PF3. Phosphorus, as you know, that is present in group 5 normally, that contain like the outermost shell containing 5 electron. So it means here are the 3 phosphorus that are combining with the 3 fluorine that are combining with the phosphorus, while there will be one lone pair on its surface. Okay, so now it will make a pyramidal shape. So the shape is pyramidal. Okay, and now PF3 contain how many lone pairs, how many bond pairs? So you will see that there is only one lone pair while the 3 bond pairs. So here I am going to write 1 lone pair and 3 bond pairs around phosphorus. Okay, so here you can compare the xenon tetrafluoride and PF3. So you can see, so the shapes are different. One is square planar and one is pyramidal, and one contain like the more fluorine, you can say 4 bond pairs. The other one contain 3 bond pair. One contain 2 lone pair. The other one contain 1 lone pair. Okay, around the central atom. Now in case of, now you have to find the relative strength. Here I am going to write the third part, that is the relative strength. Okay, so the relative strength, if we compare the relative strength of xenon tetrafluoride and PF3, so we know that like in xenon tetrafluoride, the intermolecular force that is present in the xenon tetrafluoride, that is van der Waals force. So here I am going to write the xenon tetrafluoride contain, like I am going to show you van der Waals force. So here I am going to write VW VDW, okay, like the van der Waals force. While the PF3 that contain dipole force. Alright. Now the next one, like why, if the xenon tetrafluoride contain a van der Waals force and PF3 contain like a dipole force, so as we know that the dipole is more stronger as compared to van der Waals force, so it should be, the PF3 should be like higher melting point as compared to xenon tetrafluoride. But here you can see that the melting point of xenon tetrafluoride is higher as compared to melting point of PF3, because here the intermolecular forces that are present in the xenon tetrafluoride are much more stronger. Here I am going to indicate, that is much more stronger than dipole, or you can say then PF3. Okay, why? Because when we compare the two structures here, so we will see that that is like you can say that xenon tetrafluoride has larger molecular mass, or you can say has larger like the atomic like the compound size or the molecular size. Okay, so due to that in xenon tetrafluoride there will be more electrons and they are packed closely. It means that here you can say why much more stronger van der Waals forces in xenon tetrafluoride, because the molecular ratio or molecular size of like the xenon tetrafluoride is much greater as compared to PF3, so more electrons are packed closely together. Okay, so that's the reason in which like the xenon tetrafluoride has more molecular mass. Sorry, the xenon tetrafluoride has more like the melting point or higher melting point as compared to the melting point of PF3. So that is your question number 7. Okay, now the question number 8 is little bit tricky, because here is the lengthy question. Like here is the information: a student does an experiment to determine the percentage of the mass of sodium chlorate, the formula is NaClO, in a sample of bleach solution. The method is, the first one is dilution. Here I am going to indicate that is the dilution, in which 10 centimeter cube of sample of bleach solution to 100 centimeter cube with distilled water. The second one is like you can say acidification, that is the second method or second step. Transfer 25 centimeter cube of dilute bleach solution to a conical flask and acidify using sulfuric acid. The third one, that is add excess potassium iodide to a conical flask to form a brown solution containing iodine. So here you can see I2. So that is your third step. Now the fourth step, that is add 0.10 mole per decimeter cube sodium thiosulfate solution, and the formula is given, to a conical flask from a burette until a brown solution containing I2 becomes a colorless solution containing I negative or I ion, iodine ion. Okay, so iodide ion. So that is your fourth step. Now here the student uses 33.50 centimeter cube of sodium thiosulfate solution, and the density of the bleach is given and the equation is also given. So the question is, use all the information given to calculate the percentage by mass of NaClO in the original bleach solution. Give your answer to significant fig. 3 significant fig. Okay, first of all, here we have to see that here is the thiosulfate. You can see that the 2 moles of you can say S2O3 ions that are present. So it means we have to find firstly the thiosulfate moles, okay, or you can say here that is S2O3 ions moles. Okay, so here you can see that the volume that equal to 33.50 centimeter cube. So first we need to convert the volume centimeter cube into decimeter cube. Okay, so that will be, here I am going to write N that is related for S2O3, okay, minus 2, that will equal to 33.50 divided by 1000 and times by here how much, like you can see here first, that is the concentration is 0.100 moles per decimeter cube. So you know that N is equal to V times like C. So here the concentration is 0.100. So that is, like you can say, that is M1 or step 1. Okay, so that will equal to 0.00335. okay, that is moles for thiosulfate. Okay, now the next one, here you can see in this equation that is going to react with iodine and when we compare the molar ratio, so there is 2:1. So it means that iodine will contain half mole as compared to S2O3 ions. So it means here the step 2 is actually M2 divided by 2. That is the step 2. So here N of iodine I2 will equal to 0.0335 divided by 2. Okay, so that will equal to 0.001675. okay, that is your second step. Now the third step, we have to compare, like you can see here is the iodine, and now we can compare the iodine ion, like iodide ions with chlorate, okay, or iodide ion with, like you can say, the like chlorate. So you can here M3, it means that here the M3 will equal to M2. So it means that that will contain equal amount of moles, like here the iodine mole and the chlorate mole will equal to each other, like because here iodine is 1:1, okay, 1:1. So it means there will be equal amount or equal moles of iodine as compared to chlorate. I am going to indicate here M2. Now we are going to solve step 3. So it means M2 will equal to M3. So that is our step 3. So it means here N of ClO negative is equal to 0.001675. okay, but remember that those moles that are in 25 centimeter cube, okay, not 100, because 100 will be 4 times of 25 centimeter. Okay, so it means that is in 25 centimeter cubes. So here I am going to indicate it. Okay, now the 100 centimeter cube contain how much? So NCLO negative is equal to, the 100 means 25 times 4 equal to 100, so it means we have to multiply it, and the answer will be 0.00670. Okay, so that is, like, you can indicate that is the M4. Okay, or the step 4. Now that is actually NCLO in the original 10 centimeter cube of the sample. You can see here the 10 centimeter cube of sample bleach solution to 100 centimeter cube. Okay, so it means that here the chlorate ion that will be equal to 0.00670 moles in 10 centimeter cube, or in the original 10 centimeter cube sample. Now we can easily, like, here the moles are given, so we need to find the mass of the chlorate. So mass of the chlorate, as we know that mass is equal to moles times molar mass, so here it would be like the molar mass of the actually sodium chlorate. Okay, so here M5, I am going to indicate M5, that we have to find the mass. So mass is equal to moles that are equal to 0.00670 times, now NaClO, the sodium chlorate, that will equal to 74.5. so it means here the answer will be 0.499 grams. Okay, so that is the mass of sodium chlorate that is used. Okay, now we have to find the percentage by mass of the sodium chlorate in total mass of the bleach. Okay, so now we have to find the mass of the bleach, M6, mass of bleach. So here you can see the density is given, as we can see that the density is given and the volume is also given, that is like 10 centimeter cube. So it means we can easily find out the mass. So mass is equal to, here mass, here I am going to indicate that is bleach, that will equal to, like, the density is, the volume is 10 times the density is, I think, 1.2, yeah, 1.20, like, because we don't need to convert it into decimeter cube, because here you can see the density is already present in centimeter cube. Okay, so here it would be the centimeter cube will cancel out, so it means the only grams will left. So it means here the density will equal to 1.20, so the total mass of the bleach, that will equal to 12 grams. Okay, now as you know that the percentage will equal to, like, the sodium chlorate divided by the total bleach mass, the mass of the sodium chlorate divided by the total bleach mass times 100. So it means here, like, the M7, I am going to indicate here, M7 will equal to the percentage by mass of NaClO is equal to, now here the mass of the sodium chlorate is 0.499 divided by the mass of the bleach, that will equal to 12 gram times 100. So that will equal to 4.16%. So that is your answer. Okay, so it means here the answer is 4.4.16%. Okay, because that is 7 marks question, so it means you have to solve each step one by one. Like you can see here, normally there are the 7 steps, so that like each step contain 1 marks. Okay, now 8.2 is the total uncertainty of the two readings, and the endpoint error is using the burette is like plus minus 0.15 centimeter cube. What is the total percentage of uncertainty is using the burette in this experiment? So here you can solve it like the total uncertainty, so by adding and subtracting them, so that will equal to 0.45 centimeter cube. Okay students, so that is your question number 8 completed. Now question number 9 is, this question is about sodium halides. So question is, state what is observed when silver nitrate solution is added to sodium fluoride solution. Okay, so that is about like the halogens. Like let's suppose we are going to I am going to show you, but you don't need to solve it, you don't need to like write the equation. So it means here is the silver nitrate react with silver like sodium fluoride, so there will be a double displacement reaction in which it will form silver fluoride and sodium nitrate. Okay, so that is in our solution form, so it will make a colorless solution. Okay, now the next one, state one observation when solid sodium chloride react with concentrated sulfuric acid. So as we know that, for example, I am going to take like 1:1. So let's suppose I am going to write here NaCl react with H2SO4. So here you can see that it will form what? There is double displacement reaction. So it means that may be forming NaHSO4, or you can write Na2SO4. Okay, because that is two step reaction, so here I am going to indicating in only one step. So it will form Na2SO4 plus HCl. Okay, now here you can compare, there are the two hydrogen, there is only one, so it means you need to multiply here by 2, and there is only one sodium, there is two sodium, so it means you need to multiply by 2 here. Okay, now the equation is balanced. So the question is, write the equation. So here I already wrote. Okay, now what will be the your observation? Like you can see here is the evolve of hydrochloric acid. So actually the hydrochloric acid, that is actually like a gas, so it means here is the production of white fumes gas, or steamy or misty or steamy or white fume gas. So here I am going to write observation is white fumes gas. Okay, an equation I already wrote here, you can see, or you can write here like NaCl react with H2SO4, it will form NaHSO4 plus HCl. Okay, both equations are correct. Now the role, what is the role here? So you can see like that is actually there is the proton acceptor take place, like that is role is proton acceptor. Like the role of chloride ions, state the role of chloride ions in the reaction. So the role of chloride ions is, or role of chloride ions are proton acceptor. How? You can see like in this equation, so that will easily helpful for you to indicate, like in this case there is again like a proton acceptor, and here is also in the product there is also like a proton acceptor, okay, like the chloride ions. Now the question is question number 9.3. Give an equation for a redox. Like redox reactions are those reactions in which oxidation and reduction occur at the same time, okay, like between solid sodium bromide and concentrated sulfuric acid. Explain using oxidation state why this is a redox reaction. So we have sodium bromide, here I am going to write NaBr react with sulfuric acid H2SO4. So there is again like a displacement reaction, but there are some more products that are formed. So there will be the first one that is forming like sodium sulfate, that is like you can say Na2SO4, that is our one product. The second one, that is like there is also like a bromine that is present, so it means there is a conversion, so it means there is bromide ions are also converted into bromine. While the third one, that is forming like sulfur dioxide gas, and the fourth one, that is water molecule, okay, because here are the H2 are also present, that will be combining. So now you can balance the reaction. So then there will be like you can see Na2, so it means there will be 2 moles, while here Br2 balance, and now there will be sulfur, there are 2 sulfur, so it means you need to multiply here by 2, and now there are 4 hydrogens, so you need to multiply by 2 here. So I think now the equation is balanced, okay. So explain using the oxidation state why this is a redox reaction. So as you know that redox reaction that contain oxidation and reduction, all right. Oxidation, as you know that is the loss of electron, while the reduction is gain of electrons, okay. So in this case we have to identify which species that will lose the electron and which species that will gain the electron. If you see the bromide ion here, the bromide ion, the oxidation state of bromide ion is -1 here, okay, but here you can see that is present in a like Br2 form, so that will contain a 0 oxidation state. So it means here is the conversion of -1 to 0. So that is what -1 to 0, it means there will be loss of electron take place, like increase in the oxidation state, minus to 0, negative to 0, so it means there will be oxidation take place, okay. While SO4 same, but now you can see here is the sulfur and that is the sulfur, there will be oxidation states are different. How? Like in this case, let's suppose I am going to find the oxidation state of like sulfur in H2SO4 that contain 2 times +1, that is for the hydrogen, plus X is for the sulfur, plus 4 times -2, that is for the oxygen, and that overall equal to 0. So it means here is 2 plus 4x minus 8 is equal to 0, x minus 6 is equal to 0, and x is equal to +6. So it means here the oxidation state that will equal to +6, okay. Now the next one, in SO2 you can see here the 2 oxygens, 1 sulfur, so it means the total oxygen state is -4, so sulfur should be +4. Now here you can see the sulfur is converted, the oxidation state will change from +6 to +4, it means there will be decrease in the oxidation state, so there is reduction occur because the gain of electrons take place. Okay, so you can write here the explanation is why that is oxidation, why that is redox reaction, because like bromine that will change from -1 to 0, while the sulfur that will change from +6 to +4. Okay, so here is what happened, oxidation, and here is reduction. Okay, now the next question is, state what is observed when aqueous chlorine is added to a sodium bromide solution. Give an ionic equation for the reaction. So first of all, you have to write the ionic equation, so it means you don't need to write like the metals are as well. So that will equal to Cl2 react with like the bromide, sodium bromide. So that will equal to 2Br negative. So here is the conversion, so that will make Br2 plus 2Cl negative. Okay, so you can see here the chlorine will change from 0 to -1, while the bromine will change from -1 to or -1 to 0. Okay, so there will be a yellow solution form or yellow or orange solution. Let me write here. Okay, because you can see here is the bromine gas production, and there will be like the sodium chloride formation take place. Okay, so that is end of question number 9 here. Okay students, so now we are going to start question number 10, in which like the methanol is formed when carbon dioxide and hydrogen react. It will form methanol and water. Contain enthalpy of the formation and entropy data of these substances. So here the table is given, in which del H and S is like that is present here. So use the equation and data in table 5 to calculate the Gibbs free energy change del G in kilojoule per mole for this reaction at 890 Kelvin. Okay, so first of all, as we know that del G is equal to del H minus T del S. Okay, that is the formula in which we can find del G, the value of del G, okay, delta G. But here, first of all, we need to find delta G value and delta S. Okay, so as we know that del H is equal to here product minus reactant. Okay, so here the product will equal to -201, and that will be plus minus minus -242. Okay, and then here minus into -394, that is the reactant, where the hydrogen is 0, so we don't need to write here hydrogen. So that will equal to like -49 kilojoule per mole. Okay, that is over, like you can say like M1. Okay, or step 1. Now you need to find step 2, that is M2, that is delta S. So here I am going to show you with different color. Delta S is equal to, again, like the product and overreactant. So but there are, if you see in the question, there are the 3 moles of hydrogen, so it means we need to multiply 3 times 131 here. Okay, so then that will equal to, again that is 238 plus 189 minus here is 214 plus, and 131 times 3 393. Okay, so when we add them, so 393 plus 214. Now, so first, that is here 607 minus, here is 238 plus 189, so that equal to 427. Now we need to subtract 427 minus 607, so that will equal to minus 180. But you can see in the table that is not kilojoule per mole, that is joule per Kelvin per mole. Okay, so that is joule per Kelvin per mole. So when we need to convert, so it means M3, that is we need to convert del S into kilojoule per mole. Okay, so then divided by 1000. Okay, so here you can write minus 180 divided by 1000. Okay, so minus 180 divided by 1000, so that equal to 0.18. Now you can put the like here, that is 0.18, that is in minus, so it means minus and minus, that will be plus. And the temperature, that is 890, here you can see, while the enthalpy change, that is minus 49 degree. Okay, so 890 times 0.18 minus 49. Okay, so when you solve this, so then del G is equal to how much? 111.2 kilojoule per mole. Okay, so it means the answer is, that is 111.2, and the unit is already given here. Okay, so the next question is like here, the fig 4 shows the how Gibbs free energy change varies with temperature in a different gas phase reaction. The straight line graph for this reaction has been extrapolated to the 0 Kelvin. So you can see here. Okay, now the question is, use the value of the intercept and gradient from the graph in fig 4 to calculate the enthalpy change del H in kilojoule per mole and the entropy change del S in the joule per Kelvin per mole for this reaction. Okay, so first of all, you need to find the enthalpy. So that is the enthalpy change del H will equal to, you can see here, that is like kilojoule per mole, that is on, like you can say intercept on y-axis. So here that point indicate normally that is about 146. Okay, so it means you can say or 145. So let's suppose I am going to take 145. So that is the del H intercept of y-axis, and that will equal to 146, and the unit will be kilojoule per mole. Okay, now we need to find the gradient M2. Here let's suppose that is M1. Now we are going to find M2. M2 is like a gradient, and as we know that the gradient is equal to like ups divided by down, like ups divided by across, sorry, not down, that will be across. Let's suppose here the ups that equal to 146 and the across that is actually like the temperature here, and the temperature would be around about, and the temperature is given, also given, you can see here, like intercept at 0, so it means that is normally 845. Okay, so that will equal to 845. Okay, so that will equal to 146 times 146 divided by 845, so that equal to 0.172. Okay, now here like the entropy change, and as we know that the here the gradient is also equal to minus del S because there is a negative value. Okay, so it means here you need to convert again because that is in kilojoule per mole, so it means you need to convert into joules per Kelvin. So here we have to multiply by 1000, so that will equal to 172. Okay, plus 172, and that will equal to joule per Kelvin per mole. Okay, so it means here the enthalpy that will equal to 146, and like the entropy that is 172. Okay, that is equal to delta S. Okay, now state what fig 4 shows about the feasibility of the reaction. Like feasibility, if you see above 0 degrees Celsius, the temperature would be like at 0 degrees Celsius, that is 845. So 845, that is on, like you can see, like at 0 state, like there will be no positive, no negative at 0. So you can see that temperature is 845 Kelvin. So it means like above 845, the reaction becomes thermodynamically feasible, while below 845, the reaction is not thermodynamically feasible. So here I am going to show you that is not thermodynamically feasible. Okay, while the above one, that is thermodynamically feasible. Okay, so that is the answer you can write here in 10.3. Okay, here I am going to write, see the graph. Okay, now the last question of this paper, that is question number 11. This question is about the glucose oxygen fuel cell. When the cell operates, the glucose molecule react with the water and negative electrode to form carbon dioxide and hydrogen gas. Okay, oxygen gas react with hydrogen ions to form water at positive electrode. Deduce the half equation for the reaction at a negative electrode. So negative electrode means where, like you can see here, like I am going to write at negative electrode, that would be like the loss of electron here is glucose C6H12O6 react with water molecule. It will form carbon dioxide plus, now you can see here, like first of all there are 6 carbons, so it means you need to add here 6. Okay, and now there will be 6 hydrogens to here. Now there are how much? So at negative electrode you can see here like 12 and 12, total 24 hydrogens. So it means we have to add here 24 protons. Okay, when there is the evolve of the 24 protons, so it means there will be 24 electrons too. Okay, so that is the half equations at negative electrode. In case of positive electrode, what will happen? In the positive electrode here, the oxygen actually, that will, like you can say, here is the oxygen, like that is gain the electron and proton to convert it into water molecule. Okay, let's suppose here I am going to write 2H2O. Okay, now you can see here the 2 oxygens, and here are the 2 oxygens, but there are 4 hydrogens, so it means we need to add 4 hydrogen here, like in the form of 4 proton along with 4 electrons. Okay, so that reaction occur at positive electrode. Okay, so now the next question is 11.3. Give the equation for the overall reaction that occurs in glucose oxygen fuel cell. So as you know that is very common equation, and that is also known as like the photosynthesis, like in which not photosynthesis is actually the breakdown of like the glucose. Normally in biology that is known as like respiration. Like here is C6H12O6 in the presence of oxygen, that will convert it into carbon dioxide and water molecule. Okay, so now you need to balance it, so there will be 6, 6 and 6. Okay, that is the equation here. Now 11.4. The negative electrode is made up of carbon and the positive electrode is made up of platinum. Let's suppose I am going to write here carbon and here is Pt. Okay, now give the conventional representation for the glucose oxygen fuel cell. At carbon negative electrode, so it means there will be glucose C6H12O6 along with protons and carbon dioxide, while the other side there will be, like you can say, oxygen along with protons and water molecule. Okay, at platinum. Okay, now next question 11.5, and that is your last question. State what must be done to maintain the EMF of this fuel cell when in use. So as you can see, there is like the use of the reactant, there is like you can say consumption of the reactants. So it means that when we have to maintain the EMF of this fuel cell when in use, so it means we constantly add reactant or we constantly add glucose. So here I am going to write add glucose constantly. Okay, or you can say keep, like, or keep the reactant concentration constant. Okay, so that is here the last question. So now there is the end of the question. I hope you would like our video, and the other two parts are also available on our channel. And thanks for watching. If you are new, so then please subscribe us and do support our channel. Thank you. We'll see you in the next video. Goodbye.